Hi everybody. In this video, we're going to learn how to tell if a graph is a function by using something known as the vertical line test, which is a pretty simple test. So to see if a graph is a function, draw vertical lines. If the lines do not intersect the graph more than once, then the graph is a function. Okay, so here I have I have this equation here. So y of x is equal to the positive and negative square root of 25 minus x squared. Now this equation here actually describes a circle centered at the origin and having a radius of 5 units. So this equation actually describes this graph over here, this circle. So is this a function? Well, to find out, we would just draw vertical lines. So I'll draw a vertical line over here, let's say, and you can see that this vertical line that I drew intersected this circle at 2 points, right over here and right over here. So already I can see this graph is not a function. Okay, let's read the vertical line test again. If the lines do not intersect the graph more than once, then the graph is a function. So if they do intersect the graph more than once, then the graph is not a function. Here, the vertical line did intersect the graph more than once, so the graph is not a function. And that should make sense if you've been watching my other videos, because what does it mean if this intersects the graph twice? That means that for this input over here, so remember this is the x-axis here, so that means that for this value of x, actually has two outputs. It has this output for this y value over here, and it also has this output for this y value over here. So remember, for functions, anytime we feed the function an input, we only want to see one output. So the vertical line hitting this graph or intersecting this graph in two places means that for this input, we actually have two outputs. So by definition, this cannot be a function. All right. And just to show you that this equation actually does describe this circle over here, I'm not going to do a lot of examples with this, but I'll just plug in one number. So what if we plugged in 4 for x? Then, so if we evaluate the function of y at 4, then we get positive and negative square root of 25 minus 4 squared. So I'm just replacing the x with 4. And 4 squared is 16. 4 times 4 is 16. And 25 minus 16 is 9. So this is equal to the positive and negative square root of 9. So the square root of 9 is 3, but we're going to take positive 3 and negative 3. So we have two outputs here, positive 3. Well, you don't always write the positive symbol, but I'll just put it out there. So positive 3 and negative 3. So for this one input of 4, we got two outputs, positive and negative 3. And you can see that on this circle over here, when the input is 4, I know that 4 is hard to read, but that's a 4 over there, we actually get two outputs, positive 3. Okay, again, that is hard to see, but that's a positive 3 over there. And also negative 3. Okay, that's a negative 3. Here, negative 1, negative 2. Whoops, what did I do? Must have done something. What did I do here? Negative. Oh, I see what I did. Yeah, I didn't draw the circle well. Here, that's negative 6 here. I should have put it at negative 5. There we go. All right. So anyway, now you can see Do I want to go back and redo the whole video? No, that's okay. I think I'll leave. I hope the mistake doesn't throw you off too much. So for this input of 4, then we have 2 outputs. We have positive 3, and we also have negative 3 over here, okay? Now, something you might be wondering about is what would have happened if we had drawn the vertical line, let's say, over here. Well, then it would not have intersected this graph at all. So we would have had 0 intersections. So does that mean that the graph is not a function? Could we have just drawn our vertical line here instead of over here, or anywhere inside the circle for that matter, and said, well, it doesn't intersect at all, and therefore we do not have a function? Well, we could say that, but now I need to talk about something which I brought up in the very first video on functions, and now I have to bring it up again, this longer definition of what a function is. So I said a function from one set to another is a rule that takes each member of the input set, called the domain, and assigns exactly one member of the output set, called the range, to it. So let's talk about the domain. The domain would be the input numbers that we're interested in. So we can choose which numbers we want to include in our domain. So sure, remember, and our domain here is on the x-axis. So if we choose our domain to be all numbers on the x-axis, then by drawing this line over here, which would be in our domain, then we would say, well, I drew a vertical line within my domain, and it did not hit this graph here, so I see that I do not have a function because I want all inputs in my domain to have exactly one output. So it better intersect with that graph one time. So yeah, if we define our domain to be the entire x-axis, then sure. But for a circle like this, we wouldn't want to choose our domain to be the entire x-axis, because we're not really interested in any of the points outside of this circle. So what we would be more likely to do is to just say, you know what, I'm not interested in all of these inputs over here and all of these inputs over here. I'm really only interested in the circle itself. So I would choose to define my domain to be only the numbers from -5 to +5 on the x-axis, and therefore the only vertical lines that I should be drawing to test whether or not this is a function should be inside of the domain. All right, so they should be within this blue line that I just drew over here. So I could draw a vertical line over here, and I get 2 intersections. I could draw a vertical line over here, and I get 2 intersections. So you see, within the domain that I chose, I never have an input that has 0 outputs. I do have some inputs that have 1 output. So for example, if I choose my input to be exactly -5, then I would have exactly 1 output. That's the output of y would be equal to 0. Or if I draw a vertical line on +5, which is still within my domain, then I would have 1 output of still my output would be 0. But the point is, I would get only 1 output for this input and for this input. But since I do have all of these vertical lines here with 2 outputs instead of 1, it tells me that I don't have a function. Even if I only had 1 vertical line that had more than 1 output, then it would tell me that the graph that I'm looking at is not a function. All right? So let's move on now to one more example. All right, let's take a look at this graph, and let's use the vertical line test to see if it is a function or not. So we're going to draw a bunch of vertical lines here, and that one only intersected at one point. Let's draw some more vertical lines and see how many points they intersect in. Okay, just one. By the way, I'm not drawing a dot when my vertical line intersects the x-axis. It's only this blue curve over here, which is the function that we're talking about. Okay, so here the vertical line intersected at this point, here at this point, here at this point. So you can see for all of these vertical lines that I drew and all vertical lines that you could possibly draw, the lines only intersect with the graph at exactly one point. And that means that each of these inputs has exactly one output, which is what we want for something to be a function. So yes, this would be a function over here. And actually, this is called the sine function. This is pronounced sine. And here's how the sine graph, by the way, here's where this comes from. So what we would do here is we would imagine taking a line here, and let's say this angle is 45 degrees. Okay, so that's a 45-degree angle between this line and the x-axis over here. Okay, and then you would, for every line that you draw here, well, you basically take this and just rotate it around. And for every angle, you measure the vertical distance between where this line intersects with the circle and the x-axis. You just measure that vertical distance over there. Okay, so for example, if I were to take this line and just rotate it down all the way down here to where it meets the x-axis, then the angle is 0 and the vertical height is 0. So you can see here on the sine graph, on this axis we have the angle, and on this axis we have the height. So when the angle is 0, then the height is 0. Okay, so that's this point over here. If we take this line and we rotate it 90 degrees, right? So I just made a 90-degree angle there. We can see that when with the x-axis. So when this angle is 90 degrees, then the height of this line is at 1. So, and I forgot to mention, we're starting with a unit circle, which is a circle of radius 1. So at 90 degrees, you can see here the height is 1. Okay, so that's that point over there. And what if we were to take this and then move it all the way over here? Then this would be a 180-degree angle. All right, and the vertical height would again be 0. So when we get to 180 degrees, we get 0 there. If we take this and we rotate it even more, so we get over here, okay, so that's a 270-degree angle now. And the vertical height would be, it's actually in the negative zone, so the vertical height would be -1. So you can see here at 270 degrees, the height is -1. Okay, and then obviously I'm doing the easy points here, but the rest of this blue curve is all of the angles in between, which are not as easy to just eyeball it like I did with those easy angles over there. Okay, and what you get if you do that is you get a curve which looks like this, and you keep rotating this line, and then the sine curve the sine function would keep going like that and just keep going. I didn't do a very good job of drawing it there, but you get the idea. Okay, so I just wanted to show you where the sine function came from. I'm not going to test you on that. But again, going back to the vertical line test, you draw vertical lines, and if it only, what we want to see is that it intersects with the graph just one time for every vertical line that you draw. That means that there's only one output for each input in the domain. Okay, so that's it, and have a great day.